Alright, welcome class. This video is for our flipped classroom assignment for tonight. Hopefully you guys view this with your notes nearby, because you should be following along as I am explaining each example to you. I have 3 here, all systems that involve using the elimination method. Remember, we've talked about systems of equations twice already in this class. Systems of equations is essentially more than one equation that is solved at the same time. So as you look in example 1, we've got 2 equations, 2 variables. We want to know which each variable is. This is an example of a system. The elimination method is the third method that we're going to talk about. We've talked about substitution and we have talked about graphing already. Okay, so this is the third method that we are going to look at in terms of solving a system. The elimination method works because we try to eliminate, hence the name, we try to eliminate a variable. In math, you can eliminate variables by adding opposites together or by subtracting numbers that are the same. It's a lot easier for students to add numbers rather than to subtract. So that's what we're going to focus on. Okay? We are going to focus on adding opposites. So the number 1 step is you need to make sure that you have opposite coefficients in front of the same variable. So what that means is, as we look at example 1 over here, coefficients, they are the values in front of variables. Our coefficients in example 1 are 2, 5, 4, and -5. We need them to be opposites. 5 and -5 are opposites. They need to be in front of the same variable. They're both in front of y. If they are, second step, super easy. Add down. So, I like to put a big plus sign out front. I put my equals line, and I'm going to physically just add straight down. 2x plus 4x is 6x. They're like terms. We can add those together. 5y plus a -5y, when you add opposites, they cancel. They eliminate. They give you 0y, but we don't need to write that. -4 plus 22 is 18. Most people like the elimination method, and you can see as I'm finishing this up here with math that you guys know how to do. Most people like the elimination method because you can find that first variable very easily. At this point, I would take this and I would plug it back into either equation. I'm going to choose to plug it back into the top equation here. And so instead of an x, now I have a 3. And now I can finish solving this just like we did in the substitution method. I'll multiply those together. Subtract the 6 over to the other side. Divide by the 5. And I would find out what y is. Once I have my x and my y, I would then be able to write my final answer. So, if you need more time, you just need to pause the video and go back and look through those things. But other than these 2 steps, everything else should be familiar to you. Example 2. Solve the system using the elimination method. Our first step, make sure that we have opposite coefficients in front of the same variable. When I look at example 2, I don't have any opposites. 9 and 5 are not opposites. -2 and -2 are not opposites. In fact, they're the same. So you might have to create an opposite. An easy way to create an opposite would be to multiply by a -1. The reason why I would do that is because the opposite of a -2 is a +2. When I multiply, so long as I multiply everything in the equation by the same number, I will not change the overall value of the equation. I'll change the way it looks, and I'm going to rewrite that because that's important. I'm going to change the way that that equation looks. But when I multiply by that -1, again, something that you guys should be able to do, and you can see I have it written down there, it changes the it changes the way this looks, my second equation there, but it doesn't change the value of it. And so now I can add down. 9 plus -5 is a 4x. My y's cancel because they're opposites. 11 plus a -5 is a -4. And then again, at this point, now the rest of this question is just like things that you guys have done in this class already. I get my answer. This is slightly different. I can actually plug that in here, here, or into my new equation. Because this equation, both bottom equations, they're the same value. Remember, I didn't change the value, I just changed the way it looked. So I would be definitely allowed to plug in the -1 there. I could plug in the -1 over here, or I could plug it into the top equation. It does not matter because you are trying to find out where these two lines cross. And again, I'm going to continue to do work, and so if you need to pause, let me know. Well, don't let me know. You go ahead and pause your video. But if you would just listen as I work through with this, right, and I work down to getting what y could be, remember, we did this as a visual already when we graphed it. Now I'm just taking away the visual and I'm just working through different methods to get to my final answer. Okay? I know that these two lines are going to cross. That's where they cross. And so that's why it doesn't matter where I plug the x in. All right, one more example. Example 3. Again, remember from last question, our steps. Make sure that we have opposite coefficients in front of the same variable. When I look at example 3, I do not have opposites in front of the same variable. I also don't have numbers that are the same, so I'm going to have to create opposites. So you think to yourself, does 3 go into 5? No. Does 5 go into 3? No. They're not multiples of each other. Does 8 go into 2? No, but those are related. If I could shrink 8, that would work. Or perhaps if I could make 2 go into 8, which I can. 2 is a multiple of 8. I'm sorry. 2 is a factor of 8. 8 is a multiple of 2. And so that means I can change this 2 into an 8 pretty easily if I think a little bit. That thinking takes me to, okay, what's the opposite of the 8? Well, the opposite of 8 is -8. I could multiply by a 4 to turn my 2 into an 8, and I could multiply by a -4 to turn it into a -8. If I distribute through, again, I'm going to take the time to rewrite this. I would recommend you do the same when you do this method. I'm also going to rewrite the top equation even though I haven't done anything with it. It just keeps everything organized better. Then once you have your opposites, you add down. 3 plus a -20 is a -17. My y's cancel. -1 plus 52 is a 51. Divide by a -17. Some of you might be wondering, and once again, I found my answer for x, and I'm going to plug it back in. And so as I'm doing this work, I'm going to talk again. And so if you need to pause, just pause. But some of you may be wondering, do we always have to cancel the x? No, you do not always have to cancel cancel the y. Y is what had been canceled here a couple of times. No, you do not always have to cancel the y. You just need to cancel any variable. It just so happened in our questions that it was y. But you end up finding y is 1. And then you can write your final answer, which is -3, 1, the place at which those two lines would cross. Again, make sure that you had your notes out as you followed along with me, and we will dive more into the elimination method tomorrow.